x equals 5e to 2x. And they're also giving us some information. It's called initial condition. Why do you think this initial condition is there? What is it going to do? What is it going to help us with? Yes, I saw a chat. I don't know if it was an old chat or... Oh, it was 51. Sorry. Yes, well, we can look at 51 in 1 minute. Why do you think this condition is given here? Anyone? Give it a try. Why am I given this? To find C. And if I find C, I have a unique function, just one function that fulfills this condition. That's why the condition is there. Good. So can anyone, without the symbol, the integration, there is no need right now. I'm given f prime. So can anyone give us which function prime is this? And of course, we're going to add C to it. Anyone would like to give it a try? Please, anyone? Alex, go ahead, please. It's okay if you're wrong. So we're going to copy 5.
5
yes?
times 2.
But you have to say 2 in the denominator, right?
Yeah.
Okay, e to 2x divided by 2. That's it.
Yeah.
That's it. Now we're going to use this condition. What does this condition say? When x is 0, the answer is 1/2. When the independent variable is 0, the whole answer is 1/2. Okay, so how much is e to 0? Can anyone give us e to 0?
Somebody's saying 1.
Oh, okay. Thank you. Very good. It's 1. So then I have 5/2 plus c equals 1/2. When x is 0, the whole answer equals 1/2. I move 5/2 to the other side. 1/2 minus 5/2. How much is c? Can anyone give us c?
-4.
Yes. So 1 minus 4, yes, divided by 2. Awesome. So
Yeah.
then we have c. And now this is the most general antiderivative, but this one is a unique function. This is the only function that fulfills the given condition. Which function? This one. F of x equals 5/2 e to 2x minus 2. There is no other function from the family of functions that fulfills this condition but this one. So that's why this time we have a unique function or antiderivative. So we said this from the beginning. If I'm given a condition, I will determine a unique antiderivative. If I'm not given a condition, I determine the whole family of functions, which means it has to have c in it. If you don't like c, put any other constant. We don't care. We'll use c. Good. Perfect. So now let's look at our problem in which we are given some rate of change of some function, and we're asked to find the function. So total cost from marginal cost. Find the total cost, assuming that c of x is in dollars and that fixed costs are 6,500. What does this mean? Fixed costs are 6,500. When we produce how many units, we get the fixed costs. Anyone? So we want to look at the cost. We want to look at something else. Anyone, please? So we are given the derivative. We want to find the function.
60.
I couldn't hear you. Oh, I promised 51. I'm sorry. Do we still need to do 51? Do we still need to do 51? I'm sorry. Is that a yes?
Maddie in the chat said 60 and then she said no, it's okay.
Okay, very good. Thank you so much. Thank you. So we want to look at 60. Let's see what 60 was about. Is that the one that I read? Okay, perfect. So let's look at 60. And 60 is on 393. And we have c prime of x equals x to the third minus x. They want us to find c of x. And they want us to find c of x specifically knowing that the fixed costs are 6,500. Awesome. Good. So what does that mean? So remember the total cost, we discussed that a long time ago, is made of fixed plus variable. So variable means it depends on the number of units we manufacture. But this one is like rent, electricity for the offices, and so on and so forth. It doesn't depend on the number of units we manufacture. So X is the number of units. This is the rate of change based on the number of units, and this is given to us. They're asking us to find the antiderivative of this, the original cost function whose derivative is this. And they're telling us the fixed costs are 6,500, which means when the number of units is 0, we don't produce anything. The cost at 0 is 6,500. That's what it means. Okay, perfect. So, can anyone give us the antiderivative based on what you see here? Can anyone find the antiderivative of x cubed minus x for us, based on what we just looked at?
X cubed over 3.
Careful. We have to increase the power by 1 and divide by that number. Is that clear why?
Oh, yeah.
We are learning this. This is new. So we have to undo what we were using before, right? So now we have to increase the power by 1 and divide by that number. So that this function prime is x cubed. Is it? Yes. Bring down 4 when I differentiate, divide, simplify, and get x cubed. Minus.
X squared over 2.
Excellent. X squared over 2. And of course, I don't really want to use C at this point. I'm going to use D. Just because I don't want you to think that there is any connection between these two. Any letter. Any constant. Awesome. If you want to check, when you differentiate this, you get x cubed. When you differentiate this, you get negative x. When you differentiate this, we get 0. So now this is our given condition. When x is 0, 0, 0, d equals 6,500. Because it has to fulfill this condition. 0, 0, d equals 6,500. So then the cost function is x to the 4th over 4 minus x squared over 2 plus 6,500. So we determine the cost function from its derivative, from the marginal cost, it's called. From its derivative, we were able to recover the original cost function. Well done. Okay. I would like to move on. I know we need to practice this, so once you look at some examples and review these problems we did, you will feel a little bit better about it, I promise you. Okay. So what we studied so far in 4.1, we defined antiderivative. We defined this in 4.1. And we also looked at the indefinite integral, which is just basically a sum, right? An elongated s of f of x dx. And that is the most general antiderivative plus a constant c. Again, this is the notation for the most general antiderivative. Now, I want to write this down. We used it several times. If I differentiate this, f of x plus a constant c, what should I always get? Look here carefully. Based on what we just did, when I differentiate this, what should the answer be? I will go back to our problems here because you may not take notes. I hope you do, but let's say you're watching and then you will take notes later. So what did I say here? So this is our f of x, uppercase f of x plus the constant c. When we differentiated this, what did we get?
Is it just that one prime plus a 0?
Exactly this function. This function. When I differentiate the uppercase f of x plus c, I have to get this function. So how should I write it for the general case then? When I differentiate this, what should I get?
F prime of x.
Just f. Just the function itself. So please remember this. So when we differentiate this, we have to recover f of x. Good. Now in 4.2, we're going to look at something else. So please remember these two concepts here. Very important. Okay. 4.2. Here we're going to look at areas. And you can say, what are you talking about? What area? Okay, here's an example. Let's suppose I start with a very simple function like x squared plus 1. I'm going to choose a very simple interval, 0, 2. So this is 1, this is 2. When x is 0, of course, y is 1. When x is 1, I get 2. And when x is 2, I get 5. 3, 4, 5, right here. So here's the graph. This is the graph of function f of x, specifically on the interval 0, 2. And when we talk about area, we are really talking about here about the area under the graph, this area. Who cares? Why would I ever care about this area? Why? Here's the answer. Assuming that this function, assume that f of x is the rate of change of cost. Let's say it's this function. Let's say f of x is c prime of x. We just had an example. We have c prime of x. Assuming that this is my c prime of x. What will this area represent? That area will represent represents total cost accumulated between 0 and 2 days, months, years, whatever you want, between 0 and 2. The area itself, once I find this area, I will guarantee that that is the total cost that the business incurred between 0 and 2 minutes, 0 and 2 days, 0 and 2 months, 0 and 2 years, whatever you want. If that's the case, how will I determine such an area? It's not easy. If you tell me to find the area of a 2x4, I'll say, okay, it's a rectangle. If you're telling me it's a rectangle, and I say the area is 8. But how will I determine the area under such a graph? We have several ways of, one way to find exact, and several ways, several methods to find an approximation. Exact is only one way that we are going to look at. Depends on, there are other, I shouldn't say just one way for us here, not in general, but for us that we're going to look at where it's going to be one way. But this one has several methods to find an approximation. Right now we don't know how to find this yet. So we're going to look at some ways of approximating the area. If I approximate the area, I will say this, and I find this an approximation, I will say the area, if I approximate it, represents the approximate, not the exact, the approximate total cost accumulated between such and such. Okay? So here are the several ways. Again, what we are trying to do is, this could be not just cost, it could be the rate of change of profit. And then I will have, once I determine or approximate this area, I will determine the approximate profit between 0 and 2 months or 0 and 2 years or whatever it is, the measurement unit we have. So again,